What does it take to conduct robust metabolomics and exposomics studies? How can we make the most of existing and future samples from newborn screening? And does building global communities enable the rise of global science? These are just a few of the questions we address in this episode of The Metabolomist with my guest, Vinicius Verri Hernandes. Welcome to Season 5 of the Metabolomist podcast, where we dive into the communities that are transformed by metabolomics. I am your host, Alice Limonciel, and this year I will engage with scientists who not only use metabolomics, but who leverage it for the greater good. People who know that metabolomics is a tool that holds the promise of transforming our society, but who also understand that to deliver on that promise, metabolomics needs to be part of something greater. Projects, networks, infrastructures, they all form around a common goal and make use of the best tools at their disposal. So this year in the podcast, I talk to passionate people who build communities through any strategy, from grassroots movements to decades of networking. Join me to discover the creations of these community builders and how metabolomics is helping them advance their mission. Welcome back to the Metabolomist. Today, my guest is Vinicius Verri Hernandes. Welcome.
Thank you, Alice. Thank you for having me and for inviting me for the podcast.
Can you tell us where you come from and a bit about your studies and your work until now?
Yeah, sure. So I'm originally from Brazil, where I did a big part of my studies. So my master and half of my PhD was done there. And nowadays, I consider myself a small molecule omics person because the beginning of my career was always focused on mass spectrometry. So I started in a lab. Well, the main focus was mass spectrometry in different areas, in different fields. So we have different groups within the lab working in petroleomics, natural product. During my master, I worked in a bit of a different thing. So I worked with explosives, so more focused on forensic analysis. And then during my PhD, I already moved to metabolomics. Now I'm a senior scientist here at the University of Vienna, and the focus is mostly exposomics. So I do apply a lot of the metabolomics methodologies that I have been learning through my career. So it's a mix of both nowadays, which is very nice because it's kind of complementary, right? Even if a lot of the methods are almost the same, not exactly, but almost the same. Yes, that's how I would frame my work nowadays.
Today we're going to discuss two papers, and we chose these two to represent a bit the breadth of the work that you do. So one is very metabolomics driven and one is more focusing on exposomics. So I think it's a good overview of the span of small molecule analysis and some of the things that can be done with it. Very often on the podcast, we talk more about endogenous metabolites, but you can use the same methods to study a broad variety of materials and applying to different industries as well.
Definitely, yes.
Specifically, your work, is it more focused on method development or more the application? Because I know, for example, the first paper we're going to talk about is focusing on the cohort, but the second one is more technical. So do you do all of it or do you specialize in a certain type of work?
Actually, yes, because the paper, for example, we're going to talk on the dry blood spots is very, I would say, a clear application of the methodology, right? It's a real life application. But as I said, as my background is more mass spectrometry than anything else, I do like this part of method development. So, for instance, there was a paper that we published 2 years ago on the development of a combined targeted and non-targeted methodology that we did with some new instrumentation. So I do like that part. I'm now have a paper accepted, not out yet in the metabolomics on a new library for exposomics compound, the SMS library. So I'm let's say I'm navigating through both application and development.
Yeah, and I think you're talking about ExpoLib, right? Because I saw you present that at the Metabolomics Society meeting. And towards the end of the episode, we'll talk about the communities you're involved with and the ones that you're building yourself. But also building libraries is a community effort, in my opinion. So what drives you to build those libraries and share them?
Well, I think we are in a much better state now with the libraries, right? Data is more curated, but we still miss a lot of compounds and a lot of quality data, actually. So, especially in exposomics, as I mentioned, coming from the metabolomics field, only after I started working in exposomics was when I noticed that we actually don't look too much into that component in our metabolomics studies. And we could do much better there. Is many times I would say not that difficult. One of the main ideas we had with the Expo lead was we typically work with this set of compounds around 200. We are now increasing to 350 that are very common exposures that you would typically see even in non-targeted studies. The idea there was that we could put a tool or something that the metabolomics community could use to better annotate such compounds and bring more this exposure component to the studies. Yeah.
That's a really great initiative, I think, because I'm sure there are many scientists, or let's say mass spec scientists especially, who kind of feel that their methods can be applied to exposomics, but they don't have the tools for it. So I guess this would be the good tool to help them to get into that, and then they can learn with it.
Definitely. Totally agree.
That's really great. So I would say let's start looking at our first paper. I really like this one because I always like studies that look into cohorts and trying to kind of dissect the population and understand what are the drivers of differences and how metabolites match with this. The paper that we're going to discuss is from 2022. You're the first author. And the title is Age, Sex, Body Mass Index, Diet and Menopause Related Metabolites in a Large Homogeneous Alpine Cohort. So that's the CRIS cohort. So you were working in Italy at the time, right? In South Tyrol, which is close to where I am.
Exactly. An amazing place.
Yeah, it's a beautiful place. What was this cohort about? And then how did you work on it for this specific paper?
Yeah, so as you mentioned, it's called the CRIS cohort, so Competitive Health Research in South Tyrol. And it's a cohort that was started, if I'm not mistaken, around 2011 or so. And it's a very special cohort in the way that it's very homogeneous. So they recruited the participants from the Val Venosta Valley, or Vinschgau in Germany, if you want. So it's a very small town where nowadays they have, I believe, around 14,000 people recruited. And what we did at the time was to do metabolomics in around 7,000 of these participants. So we did targeted and non-targeted. And this paper is the first one related to the targeted analysis. That's the overview.
So maybe before we dig into the results, you mentioned you did targeted and untargeted metabolomics. What was the benefit for you to do both and not just focus on one?
Well, definitely the metabolite coverage. We had a quite good panel on the targeted, so around 180 metabolites. But we obviously wanted to increase the coverage and look more. For instance, we did not have many metabolites related to the energy metabolism, for example. So the non-targeted we did actually was using Helix, so we got more the polar component. So it was a very complementary data set, I would say.
For this paper, you chose to select a subpopulation of that population of about 7,000 participants. So what drove the focus of this study specifically?
This, as I mentioned, was the first paper where we tried to find associations with the metabolite levels and these common traits that you see in the title, right? It's age, body mass index, and so on. The scope of the study, it's much broader, of course, because the cohort, we have biochemical traits, we have a lot of additional health-related data to correlate. So now more papers are coming out focusing on specific diseases or health outcomes and so on. But in these papers specifically, what we tried to do was to see how these metabolites would correlate to the traits. And a lot of what we found there was actually already described in the literature. So it was a kind of validation of the data in a way. Basic example, everyone knows that creatinine levels are higher in males, so we could see this difference as one of the most significant. And of course, the idea would be to also see if we could find additional associations that were not reported before, and we could find a few. So I don't know if you want to dig into that right away or...
But one thing I found interesting, because the usual traits that people look at are age, sex, body mass index, and things like this. But menopause, I mean, these days is becoming more of a topic, but still, it's not what usually makes the top of the list. So what made you choose that characteristic?
Yeah, that was an interesting one because the first analysis we did was, of course, if you have 7,000 participants, you want to use as much of the data as possible, right? But when you compare, let's say, premenopausal and postmenopausal women, of course, there is an influence of age, obviously there. So in a second step, what we try to do, and this, I'm saying we because Johannes Reiner, who was leading this initiative, was the person behind it, was to select this age period, let's say from 49 to 57 years, where you could try to eliminate a bit the influence of the age component, and then compare, even if it's a smaller group, try to find differences that would be, let's say, more solid. And in the end, like if I remember it right, one of the metabolites was not anymore associated when we did this smaller analysis with this smaller data set, but most of the findings actually did reproduce in this smaller. And I think it's because, as you said, it's something that people do not look at too much. So we were curious to see if there was any kind of metabolic difference that could be new and correlated to, let's say, this perimenopausal period. So this age stage where you are in between these two periods of the pre and postmenopausal.
So you compared to different cohorts that already used metabolomics and found a lot of things that were similar. But in the end, what you're looking at is a cohort, as you said, very homogeneous from a kind of small geographic location with not a lot of exchange, I would expect, with other regions of the world. So did it surprise you that there was such a large overlap? Because we're always talking about the huge differences in metabolism between different regions of the world, if only from the dietary habits, just the lifestyle and so on, plus the genetics on top. So was it more than you were expecting, more overlap?
I wouldn't say so. And I think it's basically because of two reasons. So one is because the metabolites we looked at, they are very typically, let's say, stable and well known to be different no matter which type of population you look at. So this was not too surprising. And I don't know if there is a component there, but one direction my mind goes when thinking about that is a lot of the studies that are out there, they are overrepresented in terms of European populations and more rich countries. So I believe this is also a component that we cannot, let's say, ignore. It was actually good for us to see so many correlations that were already described, because then we say, look, it looks like our data makes sense and we can move forward and try to find more correlations and associations with different diseases.
You mentioned that one of the difficulties was the overlap between the effects of menopause and age, for obvious reasons. One question I really like to ask when we talk about a paper is always what were the things that kind of complicated your work. So beside that aspect, and it can really go from the structure of the data to the analysis to some logistic issues with sample processing. Can you remember something that comes to mind where you really had an issue and you managed to solve it? Because I always try to give some ideas also for the audience on what could help them.
Well, I think in a study like that, it's just not expected that everything will run smoothly from the beginning to the end, right? Just to give you a number, we had in total with these 7,000 participants, we had roughly 96 well plates to run. So this is not a few plates, and besides that, the data we acquired was both using the LCMS but also the flow injection analysis, SOFIA. So each analysis would be, let's say, 2 analyses in the end. So I think one of the challenges in that case is to really keep it going in the sense that you are sure that your mass spec is running well, that you do proper system suitability, that, because in our case, for instance, if one plate would, I don't know, completely go wrong and we could not rerun it because we were trying not to rerun a plate that, I don't know, was in the auto sampler for a day or two, we did have some backup plates. So we had, if I remember correctly, 3 plates in total per participant or per part of the study. So there was some backup, but of course, the goal is not to use them, right? It's really to be a backup that maybe you can use for something else.
Yeah.
So the main challenge, I think, was, at least in the data acquisition part, was to keep it running smoothly. We had this, as I said, as expected, some downtime with the instruments, but it's always the thing that you try to fix yourself, otherwise the company comes. But yeah, if I would have a solution, or at least an advice, would be system suitability and quality control check, because that's really important for such studies. Yeah.
Yeah, I think it's really, especially for cohorts or other types of studies where you have so many samples and you want to be able to compare them all. This is where you focus your attention. So it's great that you managed to figure that out.
and even if you do a great job, of course, there will be differences. So this was the challenge that then Johannes had later on, to do the proper normalization and look into that. So that's also a challenge, but that was less on my hands, I would say.
Okay.
But yeah, important as well.
Anything else you want to tell us about this paper, about this study?
Well, I think it's a nice study to showcase the power of these big cohorts, right? As I said back then, it was, I think, one of the largest cohorts we had in terms of a single location, which was super nice. There were other findings. I would just invite the people to read the paper, because one, for example, that I can mention that comes to my mind that was really interesting to see was there was a significant association of serotonin with age, for example. And we could even estimate, at least within this population, what was, let's say, the drop of serotonin per year. So it was almost 0.9% per year that serotonin would drop. Wow. So, of course, we need to consider many other things, and that doesn't itself explain any story. But it's a nice story on itself, just to
something to dig into.
Trend. Yes, or the association of serotonin with higher herbal tea consumption was one of the highest associations, the strongest associations we had, which was also curious to see, even if you would correct for the seasonality, for example. So there are some really interesting findings on that paper. So I invite everyone to read it.
Yeah, this is always for me, the fun part of looking at these papers on large populations, where you find these kind of gems, exactly as you said. Like, I also saw it's really striking on the figure, the serotonin and the herbal tea, and you go, what does that mean? Where is that coming from? Exactly. And then suddenly you want to know what kind of herbs.
Yes, definitely, 100%. And if I may complement, I think another thing that comes to my mind is also that this data is actually now available, not only, let's say, in a metabolomics repository, but there is actually the CRIS portal, which you can request access to the data, and people can also use the data to dig into other traits or other diseases and things like that. So I think it's a very valuable resource.
Yes, and it's another, I mean, I'm always looking for these connections to communities this year, but this is another very active community between cohorts. I think when you organize such large, complex projects, it's really become a habit now that people try to share as much as possible and to connect as much as possible with other cohorts. So everyone either has their own portals or tries to have their data hosted on other portals, and it's really great, because then you can compare, you can do meta-analyses of more data sets.
Definitely, it's a good direction to go.
Absolutely. I think we're ready to discuss the second paper.
Okay.
So now we're moving to the field of exposomics. So similar methods, but different types of analytes you're looking for, even though you can combine the two together, of course. And this one is a little bit more technical. So we're looking at dried blood spots. And the title is Dried Blood Spots Analysis for Targeted and Non-Targeted Exposomics. So this is from 2025. So as I said, it's much more technical, which is also super interesting, because I think this is one of the best ways not just to help people to adopt methods, but also to understand which parts of the methods is most interesting for them, what they can gain and what they can lose with different setups. So what was your goal with this paper? What were you trying to dig into and provide information for?
With this paper, we wanted to see, are dried blood spots feasible for multi-analyte exposomics, right? Because there are many studies that already show the use of dried blood spots for, I don't know, maybe bisphenols or nicotine or other, let's say, exposure compounds. But with this broad coverage that we try to bring in the paper, I think it's the first one of its kind. So the idea there was, again, when we look at these 200 and some analytes that we have here in-house that we typically look at, the idea was to see, are those feasible to be analyzed in dry blood spots? Of course, there's the quantitative aspect, which we can talk about later. But the main idea was to compare 4 different extraction procedures and look at compound recovery or matrix effects. And it was not a full validation, but we looked into all these figures of merit to say, look, I don't know, 80% of the compounds do work fine. We can really use dry blood spots for that. Or this class of compounds are not good enough and things like that. So it was a feasibility study, I would call, and an optimization study at the same time. Yes.
I know we've also worked with dried blood spots, so for metabolites and lipids. And my feeling working with that matrix is it's really, really useful. Also, just the possibility to sample people at home, that they don't have to go to the hospital or to the doctor. So it's really valuable as a society level. But my feeling is, to use it best, you have to understand what you can't do with it. Is that a fair assessment?
That's a 100% fair statement. And again, that was also one of the things we wanted to say in the paper, like this you cannot do and this you can do. Because of course, it's not the perfect sample type, but as long as you know the limitations and you know how far you can get, it's good enough. And if I may also mention, of course, nowadays you might have better options than the dry blood spots cards, the Whatman cards, because you have a lot of new microsampling devices that are more quantitative and so on. But the idea that we went for the dry blood spots is that those are the type of samples that are available in the newborn screening. So we wanted to move in that direction. We are actually now running samples from the newborn screening here in Austria. And that was the reason we decided to choose the dry blood spots. Yeah, the traditional ones.
And it's great because, I mean, this is applicable to most countries in the world now, because a lot of countries run these newborn screening for decades now. And I mean, there are people running metabolomics on samples that were collected 10, 20 years ago on dried blood spots. Yeah. And so the question is, can you also look for exposures now retrospectively in those samples, which are biobanks are full of them, hospitals are full of them?
Yeah, definitely. That's the question we are also asking ourselves. So we do not have the answer yet, but that would be an idea. For instance, we have a study now that we are running on, let's say, plasma samples from a cohort in Italy that they collected sample before and after women developed breast cancer. And these are samples that are coming from the 80s. So very, very likely there were different exposures back then than the exposures we have now. So
for sure,
this would be definitely something interesting to look into the dry blood spots. Of course, more questions and limitations come. But again, as long as you know what's feasible and what's not, I think it's very much doable and a very interesting thing to pursue.
I would encourage the audience to really look into your paper in detail so that they can, understand what fits best for their science. But for yourself, what are the main things you learned, or like the highlights that you keep from that study? What works, what doesn't work?
I was actually surprised to see how well most of the analytes worked. So especially when we look at the compound recovery and the matrix effects, it was not, let's say, as bad as someone might imagine, because you have the dry blood, you have the card, and there's a lot of things in there that might really get in the way of your analysis. But most of the compounds we looked at were quite good in terms of stability. We spiked on different levels also to see if there was an effect there. So I think that the what we took from it is that, okay, this is doable. We know which compounds are working. We know which compounds are more tricky,
Mm-hmm.
and we can really move forward. And as I said, that's what we are doing now. That we are
Mm-hmm.
at the moment running 750 samples from the newborn screening here in Austria. Keep an eye on the work, because soon, hopefully next year, we'll have more news related to that.
Mm-hmm. And I'm wondering, because as we discussed, newborn screening samples often are kept at various temperature levels for many years. So are there any models already that kind of predict how quickly different chemical structures degrade over time? Does that exist?
Not really. This is definitely something we need to look into, especially if we decide to go for this more retrospective analysis. What I could imagine, a lot of these compounds that we look at least some of the compounds, they are called these forever chemicals. They are compounds that are known not to degrade no matter what you do with them. People are trying to develop methods to degrade them. Of course, as I said, it's a part of the compounds we look at. And anyway, we have to look into stability. But I would guess that for many of these compounds, you have quite a stable.
Okay.
And another thing we have to consider and really dig into is, okay, even if they are stable, as you mentioned, these samples are just stored there for 10, 15 years, room temperature in a cabinet. They are still being exposed to things from the air or from people touching the cards.
Yep.
So this is also a component that we need to understand how it's influencing the samples and the results we see.
Yeah. These are all the fun investigation points that you get to play with when you plan an experiment.
and that's why I love to work with these kind of samples, because they are challenging in a way. There's a lot of questions unanswered. So I think there's a lot of space for research there.
So you went from metabolomics to exposomics, if I may simplify it that way. When you go to the interpretation part, like when you really try to understand what's going on in a system or in a cohort, is it a different game to try and imagine the story when you're purely looking at the endogenous metabolites, or where you're starting to combine different exposures and scenarios, like kind of amplify the backstory of your samples somehow?
I think so. And as you said, you have to have a kind of different view, right? There are different statistical methods and tools that people use to do that. So, of course, when we talk about exposure, one thing is just to, let's say, report, okay, we found this and this and that. But ultimately, our goal is typically to try to find correlations or associations with some health outcome or whatever disease you're interested in. So you have to find ways to consider, for example, toxicity, daily limit intakes, and things like that into your, let's say, statistical models or mixture models, because you need exposures do not happen once at a time, right? They are a combination, they interact. So all these kind of factors are things that we typically don't need to worry too much about in metabolomics. So it's a different perspective. And we are also trying to get in that direction, that we can not only detect exposures, but we can try to find the important associations. Because it doesn't mean that if you find 100 exposure compounds in your plasma, that all of them will have an impact. So that's the difficult component to get, like what is really important in there.
Yeah. And speaking of these associations, if you take the question from maybe the other side, from which I would typically take it. So if you start from the exposure and you want to look at the effects in humans, for example, would metabolomics be the first omic you would combine it with, or would you start with something else?
Well, I'm biased to say, because I would definitely go for metabolomics. But I think there are, for example, epigenetics changes that can happen. So there are groups, we don't work on that specifically in here, but I know of many other groups. For example, IS Global in Barcelona, they are doing a lot of transcriptomics, genomics, and other types of omics. So I think all layers are important. But again, metabolomics, the closest one to the phenotype, the typical story.
To conclude on this paper, because this is a podcast probably mostly listened to by people from metabolomics. So someone who would want to, for example, use dried blood spots for both metabolomics and exposomics, I would encourage them to first look at this paper. But would you have any advice on like the first things to think about or the first things to consider?
Mm-hmm. I would come back to know the limitations. So as I said, dried blood spots are not the easiest to sample to work with, but you have to know that it's typically not quantitative, right? For example, a very simple example, like when we wanted to do the recovery estimation for our compounds, if you do recovery, you have to have a pre-spiked sample. How do we spike the sample? Do we spike the DBS directly on the card? Do we spike the blood and put on the card? So there's still no sort of more harmonized guideline on how to look into this. So an advice I would give is first read a lot about dried blood spots, know the limitations, but also for metabolomics, it's quite well implemented as well. There's a very nice group of people doing a lot of the technical, let's say, development for metabolomics in dried blood spots within the Human Doctoral Network. Just look at what other people are doing because it's always a good starting step.
Yes, very good advice. So I think we're ready to move into one of the last parts of our discussion where we really focus on the communities that you're a part of and some communities that you're building as well. From the paper we were talking about, I would start with Irene because this is an exposomics community that University of Vienna is a part of and that you're also contributing to. So can you tell us a little bit about Irene and also how you've seen it grow and develop as a part of it?
Yeah, so IRENE actually stands for European Infrastructure for Human Exposome, and as the name says, it's a research infrastructure. So for me, it was also something new when I joined IRENE because I did not have yet this concept of the research infrastructures, which are not a typical, let's say, European project, but it's something that is supposed to last very long term and become a legal entity, actually. And the idea of the research infrastructures is that they would provide state-of-the-art services for people doing whatever research they are focusing in. So in the case of IRENE, it's exposomics. It was a very nice thing to see how it developed, because when I started working here, I was right away within IRENE. And that was the year that we kind of launched the Austrian node of IRENE. So I let's say I saw it from the beginning. And basically the idea at the European level, so it's a pan-European initiative with, I'm not sure now how many countries, but I would guess 15, 20 countries in Europe at least, and more countries outside. And the idea is, as I said, that we develop all the methodologies, that we do harmonization, and we later on become a legal entity in Europe that is able to provide the services to anyone in the community that wants to use the service. So that's the goal of IRENE. Yeah.
It's a really smart model, I think, because as you mentioned, it's very different from what people in Europe understand as the usual European project. So the European Union funds a lot of research, but this is really the next step where it's, I think, leveraging the scientific communities that it has funded and helps them to really build, in the end, money-making infrastructures that support standardized or let's say harmonized science across the different countries. So it's really a cool initiative and a really smart idea, I think.
Yeah, and I think that's one of the main components that is a sustainable idea. So the idea is that it will be there for people to use, and the goal is also not that it works as a sort of core facility where people require the access and pay for it. So there's also, that can be done as well, but there's also another type of access that is called the open access. So people just apply with a project and the best projects are selected. And these are actually fully covered because these are funded by the different governments that agree to be on board of IRENE. So that's also very interesting, let's say, model to keep the sustainability and at the same time help researchers that maybe across the globe do not have the fundings or the capacities to have such type of services.
So it means that scientists from non-European countries can apply for this?
Definitely. And nowadays also researchers and institutions outside of Europe are also actually formally part of ARENE. So you have people from the US, where you have also a big community there for exposomics within the Nexus initiative. But you have people from Japan, from Australia, from Canada. So it's really becoming a global initiative, even if it's, let's say, European focused in a way and started in Europe. But it's supposed to be a really global initiative.
And I find it really interesting because with exposomics, it quickly gets global. And it's something that I haven't seen in many scientific communities. And I'm wondering, is it because of what this community studies, because like toxins and environmental things kind of travel quickly? Or is it a consequence of a science coming of age at a time when maybe scientists are better connected? What's your feeling about this?
I think both of them influence. So as you said, this environmental component that is much more within the exposure, the exposomics science, definitely I think helps to make it more global, right? One thing I can notice between the two communities is that the exposomics community has much more of a political agenda, right? Because it's connected to climate change. And also because when I think about metabolomics, the community doing metabolomics is basically, yes, LCMS, GCMS, NMR community doing this kind of course, you have biologists and all the different know-hows within it. But this is much, much more broad within the exposomics community because you have people doing, working with satellite data that are doing exposomics. Literally, the name is exposomics. So it's a much more diverse community, and I think that helps in making it global.
Yeah, and I think for the audience, we should specify that really the exposome goes far beyond chemical exposures that we measure with mass spec or with NMR. There's also psychosocial impacts and things like this. Like it's really trying to get all the influences that will be to some extent measured in your metabolome. So you can also say like stress is something you can measure in the metabolome, the impact of it. But there are tools to measure all these different exposures and combine it with different omics or different biological measures together. So it's really a fascinating field. That's why I never tire of talking to people from the exposome field, because I think it ties really nicely with metabolomics, as we mentioned before, because we're not biased at all.
Yes, definitely. Not at all. I totally agree with you that it's such a diverse world, exposomics, and you mentioned the people working with the social aspects. You can do exposomics, let's say, only on a questionnaire base. This is also exposomics if you can get exposure based on a questionnaire, for example. So it's a very diverse and interesting field. Yeah.
There's probably a link for people to send their proposal for the samples to be measured. Does that exist already? No.
Yes and no. So here in Austria, we are already offering the services, but they are still in the format that you have to pay a fee to do it. So of course, people are welcome to get in touch with us, but we still do not have the open access format. And this is going to come in the next year. So let's say the time frame of ARENE, it's roughly 20 years for the research infrastructure to be implemented. And we just passed the preparatory phase, which was 5 years, and we are now starting the implementation phase. So this is the stage where we really solidify the methods, we harmonize and so on, and then we go to the operational phase, which will have the open access and everything running more smoothly. Yeah.
So for scientists who would like to follow the developments of ARENE, how would you recommend that they stay in touch?
Well, I think the website is the easiest way. They also have a newsletter, if I'm not mistaken, also in Exposome Austria. That's the name of our national hub. We do have a newsletter that we only send twice a year, so we are not spamming people every month. And of course, we share also updates from the European level, so from the ARENE level. So I would also invite people to subscribe to that and get in touch. Yeah.
Okay, we'll put link to both on the episode page so people can find it easily. Thank you.
Great.
What are other exposomics communities you're part of?
So one community that I think is very interesting to bring is the so-called IHAN ambassadors. So IHAN is the International Human Exposome Network. And what they did was a very nice program that they selected people all over the globe. And this is really, it was one of the first initiatives I participated that I could feel really the global aspect, where they selected these so-called ambassadors that they would, let's say, get everyone together, discuss the limitations in exposomics around the globe, get people trained. So in the format of train the trainers, so people could go back to the regions and really implement the things that they learn and get the communities, the local communities developed. So I think this, I was one of the people participating there. It was a very nice experience to me. We are meeting again now in November. And I think a lot of nice things are already coming out from that. So different trainings and webinars and things like that. But I wanted to highlight that because it was a very nice and important initiative from my perspective.
Thank you. And it's also interesting because in the first episode of this season, we had Leah Metre as a guest, and she also mentioned the IHAN ambassadors as something she was really excited about.
Yes.
And this brings us on a parallel track to one of your personal initiatives with some of your colleagues, where you decided to build a Brazilian metabolomics community. Can you tell us how you came to doing this?
I think the motivation for me was that, as I said, I was doing my master and PhD in Brazil, but then around 7-8 years ago, I moved to Europe. So I worked in Spain, in Italy, and now in Austria. And with that, I could feel like I was more integrated to the, for example, the metabolomics, now the exposomics, but the metabolomics community, because of course you have more opportunities to meet the people, to go to conferences, funding is better, and things like that. So it was really a pity for me every time I would go, for example, to a metabolomics conference, and knowing how many good researchers, for example, we have in Brazil doing metabolomics, that none of them could be there, and basically not because they didn't want, but because of funding. Or when I started to see all the regional societies that were built within the metabolomics community, I said, well, we need something like that in Brazil. We need to connect the people because we are also in a scenario that exactly because of this lack of funding and support, many times we need to find ways to collaborate and to have our studies successfully done. So what I did basically, this was a sort of a pandemic project, because it started in everyone had their own pandemic project. So I also had mine. So I basically created a website at the time, which is still live, still updated. And I started shooting out emails to people I knew doing metabolomics in Brazil. Look, we need to get together, just register here. We are starting organizing webinars and trainings. And we also had a forum where people could, post some doubts and other people could answer and things like that. So it started like that. And I think one other important component is that everything would be done in Portuguese, because again, unfortunately, it's not a reality that 100% of the people are comfortable with English or are fluent in English. So that's also a barrier that we have. Also, bringing the information to, let's say, our mother tongue was important. And it really took off. So nowadays, we have more than 1,100 people registered. So it's quite a big community.
Yeah.
We already hosted 2 or 3 different courses on basic metabolomics, data analysis, and things like that. And we actually recorded all of them. We have a YouTube channel that we put all the webinars and courses in there. So I think now it's a very valuable resource. Yeah, so I'm really proud that I could start that. And I'm really thankful for the people that helped me. Because thankfully, I always had 3 or 4 people helping me, as I do have now, not only helping me, but also taking the lead in many aspects. So without these people jumping in, it would be not possible, definitely. So
that's the beauty of a community, is that you can share the work and go forward together. I heard in Buenos Aires at the Metabolomics conference that the Brazilian community will become an affiliate of the Metabolomics Society very soon.
Yeah, hopefully, yes. Before that, because for now we have the LAMS, right, which is the Latin America, let's say, society. But we do want first to get our own, let's say, Brazilian community officially created. So, and that's what we have been working within the portal. Which is the name of the the website that I created, to get a lot of professors together and discuss the possibility. And it's now planned to happen in November. So in November, we will have a conference. It's the 7th conference of the Brazilian Proteomics Society. And since the last edition, we are doing in parallel the Metabolomics Summit, the Brazilian Metabolomics Summit. So this will be the 2nd edition now in November. And we will have a session in which we will officially create the Brazilian Metabolomics Society, because we need to be official. We need people to sign and to be there. So we're going to use this event to officially create the society. And then later on, when I think we are mature enough, of course, becoming officially part of the Metabolomics Society is the goal. Yeah,
it's really exciting. So this conference is the one where people have to show up then to be part of the movement, right?
Yes, exactly. we are trying to adjust to see if people can join also online, so they would also be considered as a funding member of the community. But of course, if you can be there in person, I think it's going to be a historical time to be there.
Is there anything else you want to tell us about the Brazilian metabolomics community?
I think I'm just proud when I think about it, because I see the quality of the work people are doing there, even if with such limiting factors around. I think it's getting in a very nice place. And I think I also have to highlight the effort of the International Metabolomics Society to do that, to include less represented researchers around the globe. So a clear example was the conference that we had now in Argentina, which was a super nice event. And it really came to my eyes the fact that almost half of the participants there were attending the Metabolomics conference for the first time. I think this really tells you a lot, that these people cannot attend unless it's regional, unless it's there. So I'm really glad to see that this is really taking off now, and also from the Metabolomics Society part. So I'm just happy and proud about it.
Is there something that you can think of where you can see like this is something we could do as a community now that would help scientists in Brazil or in other parts of the world that are working in similar conditions?
I think remember of those scientists and trying to help them in the sense of considering more collaborations, scientific collaborations, because of course it's hard that funding just flows from Europe or US to the other countries. That's much more difficult. But if you have project money that you can maybe get some interesting samples from Latin America or Africa or other low and middle income countries, that you can have partners there, I think this is something people should consider a bit more, even if, as I said, nowadays, a lot of people are going that direction. So I think that would be maybe one point that I would highlight, because, as I said, the support from the Metabolomics Society, from my perspective, it's just getting better. Now, for example, they are doing this online symposium organized by the EMN for the Early Members Network, which I think is also a very nice initiative, just because, again, people who cannot participate, who cannot travel, can feel part of the community, can present their work. So I think these kind of initiatives are what makes it inclusive in the end.
We've discussed a few communities you're part of, for metabolomics, for exposomics. We work in communities because we want to achieve certain goals together, or we want to progress science at the very least. But so from your perspective, with the communities you work with, what would success look like in the next 5 to 10 years? What is it that comes to mind when I ask this question?
I think the answer would be this going global idea, right? It's really to include researchers from other, let's say, settings, low and middle income countries. I already mentioned that because we were talking before about does this significant difference in sex between males and females, is it the same in a different genetic background? So we need more representation, not only on the cohorts, on the studies themselves, but also in leading the projects, in having the researchers that are from such countries leading the projects and participating more of the communities. And I think, again, we are a good track, but it can always get better, right?
Yes, of course. And interestingly, I think this applies to both metabolomics and exposomics communities. It's so closely intertwined, like with this idea of exposure and effects, that you can really apply the same logic to both.
Yeah, and maybe this is another direction that the two communities should interconnect better, right? Because of course I see a lot of people that I know in both communities, but I see some initiatives that could go sort of a bit closer together. So I think also reaching from one community to the other is also important, not to duplicate work and to get even, let's say, more efficient in terms of developing the research and the science.
So I think we're ready for our very last question.
Okay.
Given your specialties, I would expand to say, what is your favorite analyte and why? So it can be a metabolite or an exposure chemical. So what did you choose for this?
Well, actually, the one I chose is both a metabolite and an exposure analyte. So it covers both because, I was thinking about this question. And I know for many people, like they work on a certain metabolic pathway their whole life, and they really have one metabolite that they love. But in my case, I think my work was always so diverse that I typically have a favorite metabolite every 3 to 6 months. and recently, one that I'm a lot into is cotinine. So even if I'm not a smoker, so cotinine, it's a marker for smoking habit. And I really like it because, well, first, when we try to explain our work, for example, for people that are not from the field, right? It's we stumble many times, right? It's difficult many times to make into simple words. And with cotinine, what we see in our studies, it's so clear the difference when you have a smoker and a non-smoker. Like the levels are completely different. So it's a very clear and specific marker that we can track. And also when explaining to people that are not from the field, like, if you smoke, you have these or you not have these. And if you are a passive smoker, you have something in between. So it's a very nice example of metabolite. And also because one thing that I did not mention, I'm a lot involved into training. So we do have a training course here in Austria within ARENE that we actually invite the students to donate their own urine and analyze their own urine. So we go to the lab, we prepare the sample, we do non-targeted analysis, data processing and everything. And then in the end, we collect some metadata to try to find some statistical case control correlations. And one of the things we look into is smokers versus non-smokers. Besides, I don't know, male versus female or coffee versus non-coffee. And typically the smoker versus non-smoker, even if we have a very small data set, typically of 30 samples, you can always see cotinine as a differential metabolite because it's so clear. So I really like cotinine because of that.
And you said it's an endogenous metabolite too?
Yes, it's a metabolite of nicotine. So nicotine has a much lower half-life. So you can still detect it, but it's more acute right after you smoke. And then it's metabolized to cotinine, which has a much longer half-life. So it's typically the marker for smoking, cotinine and hydroxycotinine. So yes, it's a metabolite.
Wonderful. Thank you very much.
Thank you, Alice.
Thank you for listening to this episode of The Metabolomist, where we explored one of the many communities that leverage metabolomics for the greater good. To make sure that you don't miss out on our next episode, you can follow the podcast on your podcast app or go to themetabolomist.com and register to our newsletter. Until then, I wish you to get to use metabolomics with the same passion and the same dedication as my guest today, and don't hesitate to reach out to me on LinkedIn at Alice Limonciel with your thoughts on today's episode.